This is my Algebra 1 video that discusses one-step inequalities with addition and subtraction. This is part 1 of a two-part series. But before we start, there's something I want to go over, and that is whatever you do on one side of the inequality, you must also do on the other side of the inequality. Now you may be asking yourself, what is an inequality? Well, it is a mathematical sentence that uses either a greater than sign, a less than sign, or a greater than and equal to sign, or a less than or equal to sign in it. Here's an example. This is greater than or equal to. So we have 7 is greater than or equal to 7. This is our mathematical sentence that uses this inequality. Now this is true because 7 is equal to 7, correct? But now if I was to subtract 3 from this side and do nothing to this side, I would have 7 minus 3 is 4, is greater than or equal to 7. And 4 is neither greater than or equal to 7. So if I was to subtract 3 from this side and do nothing to the other side, it would no longer be true. So I must subtract 3 from both sides of the equation in order to keep it true. Another thing before we start, I want to go over additive inverses again. As with equations, same thing in inequalities. When you have positive 1 and negative 1, correct? They are in fact additive inverses of each other because when you add them together, the result is 0. Plus 1 plus negative 1 equals 0. This is because they are additive inverses of each other. Here's some examples. If I have 751, what do I need to add to 751 to equal 0? Well, I would need to add negative 751. This is because positive 751 and negative 751 are additive inverses of each other. Now, here's another example. I have negative 1/12. What do I need to add to negative 1/12? So the result would be 0. And I would need positive 1/12. This is because negative 1/12 and positive 1/12 are additive inverses of each other. Now we're going to solve a one-step inequality with addition and subtraction. Here we have x plus 3 is greater than 5. This is an inequality because it has a greater than sign rather than a equal sign. If it had an equal sign in it, it would be an equation, correct? So on this side of the greater than sign, we have x plus 1 plus 2 plus 3, correct? X plus 3. And on this side of the inequality, we have a positive 5, correct? 2, 3, 4, 5. So this is positive 5. Now, these are our tiles again. So what do I need to do to get the x by itself on one side of the equation and the numbers on the other side of the equation? Well, I would use the additive inverse of 3, which is negative 3. So I put in negative 1, negative 2, and negative 3. And each one of these blue tiles cancels out when you add each one of the red tiles. So you have plus 3 and negative 3 when added together equals 0. So I would have x plus 0 is greater than 5. Well, I can just write that as x. I don't need to bring the plus 0, right? But remember, whatever I do on this side, I must also do on this side. So I bring the negative 3 over here, just as I did over here. That cancels out 3 of the positive ones, and it leaves me with 2. So x is greater than 2. Now, this was our solution to the inequality that was x plus 3 is greater than 5, right? So I can't, in order to test it, I can't just put in 2. I have to put in a number that's greater than 2, correct? So I will put 2.1, which is slightly larger than 2, plus 3 is greater than 5. And that is true, because 2.1 plus 3 is 5.1, and that is in fact greater than 5. Now, how would I graph this on the number line? Here's our number line. Here's our solution right here, correct? So I would draw a circle at 2, but I would not fill in that circle because I am not including 2. 2 won't work. Remember, 2 plus 3 is not greater than 5. And then I would draw an arrow for all those numbers that are greater than 2. So as x is greater than 2, but you do not fill in this circle because it does not include 2. Okay? Here is our inequality one more time. But this time we're just going to use the inverse or opposite operation, which the inverse operation of addition is subtraction. Okay? So we're adding 3 to the variable x. So we are going to subtract 3 on both sides. And once again, positive 3 and negative 3 are additive inverses of each other, because when you combine them, the result is 0. So I would have x plus 0, or just x, is greater than 5 minus 3, which is 2. Same answer as before. Things to remember when working with one-step inequalities that use addition and subtraction. The first thing is, you want, at the end of the day, you want to get x is greater than or less than some number. You want to get the variable on one side of the inequality and numbers on the other side of the inequality. And also, very important in algebra, whatever you do on one side of the inequality, you must do on the other side of the inequality. And you must also remember that additive inverses of each other will equal 0 when added. And the inverse operation of addition is subtraction. And you must also know that the inverse operation of subtraction is addition. Things to remember when graphing the solution to an inequality. Here's our number line. We have x is less than negative 5, right? We draw our circle at negative 5, but we're not including negative 5, so we do not fill that in, okay? And then, since it's less than negative 5, we draw an arrow that includes all the numbers that are less than negative 5. You can also remember that when there's a greater than or less than sign, you do not fill in that number because you're not including that number, as in this case, negative 5. This has been an Algebra 1 video that discusses one-step inequalities with addition and subtraction. And this is part 1 of a 2-part series. You can reach me at rjansen at jansonmath620@gmail.com.